Alright, so continuing on, what we're trying to do here is show that hopefully I can use this formula to add up the first k plus 1 integers. Okay, to do that, I'm already assuming that for the first k integers, I can use this formula, that it will work. Alright, and then by making that assumption, I want to show that this is true, that for the next integer, I can also use this formula. Okay, so let's take a look at this, what we've written. We're adding up the first k plus 1 integers, and we want this formula to work. Well, to add up the first k plus 1 integers, right up till here, we've added up the first k integers. And how can I find the first k integers? I can just use this formula, because I assume that I can do that. There we go. So the first k integers, I'll just use this formula. K times k plus 1 over 2. And I'm going to add on to this sum, which is I can find using this formula. I'm going to add on k plus 1. Alright. And somehow I need to get this to look like this so that I can show that the formula works. Well, let's see. To work towards that, let's just start scrolling down here. Alright, so let's just do what we can do. Let's maybe distribute this k, so we get k squared plus k over 2 plus k plus 1. Well, I see that the formula that I want to use is all over 2, so maybe I should add this guy to that guy. Add this fraction to this thing. Well, to add two things together, we need common denominators. This needs to be over 2 in order to add these together. But I can't just do that. If I'm going to divide by 2, I also need to multiply by 2 to balance it all out. So now I can add them together. I have k squared plus k plus, well, I'm going to write this down in a little bit simplified way. I'm going to distribute the 2. 2k plus 2, and now it's all over 2. Alright, so we're getting closer. This looks more like the formula that I want. It's all over 2. So let's see, now we have k squared plus 3k, combining like terms, plus 2 over 2. And, well, here's a quadratic expression. Maybe we can factor it. Let's see if it factors. Well, we're going to need a k and a k, plus, plus. I need to multiply to make 2. The only way I know to do that is 1 and 2. And let's see, if I multiply 2 by k, I get 2k, and 1 by k, I get 1k. 2k plus 1k is 3k. So, yeah, this is the factor form of that quadratic expression. And what do you know? It's exactly like the formula that I wanted. All right, this definitely should be with a parentheses around it. If I didn't feel like factoring, I could kind of work from both ends, right? I start here, and I'm working my way down, and I want to eventually get to here, right? So this would be like at the bottom. I could write this at the bottom and say I want to get all this stuff to equal that right there. But we can kind of make the two pieces meet. I could multiply this together. This is just I don't know, a tip for using induction. I can multiply this together. If I FOIL all of this, I get k squared plus 3k plus 2. A little easier to FOIL things than factor things. So that's not a very difficult factoring problem. And so by going this way, coming in and meeting the two pieces in the middle, I could have stopped there and said, oh yeah, this is the same as that, which is the same as that, and that's the formula that I want to use. So that's just a little hint. All right. So hopefully that gives you a good introduction. Don't feel too bad if it seems still fuzzy. It's going to take a few examples for it to make much sense. So we'll do some more of those in the practice problems.